Hi there. This is playlist 8. You should discuss this material Friday, April 10th. Before I jump into the topics we're discussing today, a quick announcement about the exam. So it is going to be a self-scheduled exam. So all of next week, I will give you a 1 week window for you to choose a 2-hour time slot to take the exam. The exam is also going to be open book, open notes, closed internet, and closed other people. So it should be all of your own work, but feel free to have however much notes you want. Have your textbook out. That's all fair game. So, like I said, you have 2 hours to take it. I'll have some sort of statement at the top of saying what time you started it, what time you finish it, and sign a thing saying that it's all your own work. But beyond that, yeah, it's all in the honor system. Um, the exam's gonna be written to be approximately as it would about as long as it would be if I was giving it in class. So I'm shooting for about 45 minutes. You have the full 2 hours if you want to take it. It just shouldn't you shouldn't use more than an afternoon, more than that 2-hour time slot to actually take it. Ideally, it only takes you under an hour. Okay, so that's the exam. Other reminders, this OneNote document, so I've got these, all the different files that I've ever written on during any of these videos. This is all accessible through Moodle. You can click, there's a link on there, just in case you missed the first time I mentioned that. All right, so material for today. This is sort of our last playlist talking about Taylor series, or just talking about Taylor series. Just as a recap, the idea is that if we have some potentially weird function, we can rewrite it as a sum of a bunch of polynomials. And when doing that, that's going to let us manipulate it in ways that we can't usually manipulate it. Specifically, I'm thinking of there are functions that don't have an elementary antiderivative, and this is going to let us get around that. I'll talk more about that in just a minute. Okay, so stuff that we've talked about so far. We've talked about how to find the Taylor expansions for a few elementary functions. So I'm thinking things along the lines, our trig function, so cosine of x, sine of x, x e to the x, and sort of most recently we've talked about the binomial expansion. So anything of the form 1 plus x to some power. We've talked about how to take the Taylor expansion of that. And the nice thing about that one is that the p can be anything. It can be a fraction, it can be negative, which is going to allow us to get some more interesting functions that we can take the Taylor series of. Okay, so yes, given just about any polynomial, or just about any function, if we can take its derivatives, that's enough to be able to find the Taylor series. However, often that can be a little bit more difficult to spot, especially in these sort of more complicated functions. So rather than finding it directly, a common tool that we'll use is some sort of combination of these building block functions that we're going to combine using, for example, arithmetic like addition, multiplication, division, subtraction, or substitution, or some sort of differentiation integration technique. All right, so the next few videos, I'm going to be talking about how exactly we can combine functions, or combine the Taylor series of functions to find the Taylor series of a more complicated function. Okay. And again, sort of one of the main motivations behind this is finding something like the antiderivative of a function we can't really antidifferentiate. So we mentioned way back when that sine of x over x was one of many functions that doesn't have a clean antiderivative. And so we talked about this when we were talking about our estimation techniques, left-hand rule, right-hand rule, trapezoid rule, those types of things. The Taylor series is really just a more sophisticated technique than the trapezoid rule. trapezoid rule is using a 1-degree polynomial to estimate a function. The Taylor series is using an infinite number of degrees of the polynomial. All right. So one nice thing that we can do is we can actually come up with the series expansion for the antiderivative of sine of x over x. All right. So this is the question that I want you to work on in groups. You don't necessarily have to have this worked out before your discussion group meets, but this should be a topic that your discussion group talks about, works through. It's a little bit tricky, but I think we can all do it. Okay. I also wanted to mention an alternative to your presentation rather than recapping these videos. Another thing that you could do would be to answer this question. So using its Taylor series, show that e to the x is its own derivative.